So let's look then at our toy model with uncertainty introduced into this. And let's first do this in a simple way as is conceivable, which is the following basically. So we have uncertainty in period 1. So we start with an initial price P0 over here. And now when going from today, t equals 0, to next year, t equals 1, there's uncertainty in the sense that price can either go up to a high price, PH, or it might go down to a low price, PL. And the probability of going up is, let me call it Q here, and then of course the probability of going down will be 1 minus that Q. And now the simple thing is the following: well, once it has gone up or down, it will stay where it is. So from this point onward, prices will again remain constant forever onwards. So either they will remain at PH or they will remain at PL wherever they have gone in the first year. So again, we can ask the same type of questions. The question is again, should we invest today at period 0? Should we invest our amount I in order to get this uncertain cash flow? So getting either PH or PL across the future. So let's look again at the NPV rule, so the net present value of investing if today at t equals 1. So of course there's two scenarios here. So in one scenario the price goes to the high level, to PH, call that the high scenario. So what's the value of the cash flows in that high scenario? Well, we have high price, PH, it's again a perpetuity. So the value of the firm in that scenario will be PH over R. But we might also end up in the low scenario, and then of course the value will be VL or PL over R. So again, these two perpetuity formulas for either the high or the low scenario. So what do we get if we invest today? Well, we don't know yet, but we get some expected value. So we know that with some probability Q we get into the high scenario, with probability 1 minus Q we get into the low scenario. So the expected value that we get is V bar will be equal to the expected price, P bar, divided by R. And so of course this expected price again is the weighted average of the high and the low price, with these probabilities Q for the high scenario and 1 minus Q for the low scenario. So now we know what the net present value rule is going to say. Well, we know what the expected value is. It is V bar, and we're going to invest whenever that expected present value outweighs the known current investment cost I. So whenever V bar minus I is bigger than 0, or in other words, whenever P bar, the average price, divided by R minus I is bigger or equal to 0. So that might be a good thing. So as long as this happens, we might make this investment. That's what the NPV rule says. Now the question is this optimal? Because now again we have to wonder what happens if we have the opportunity here to not just make the investment today, but also on the other hand we might want to wait and postpone our investment decision to t equals 1, so to next year when we know in which scenario we have ended up. So in t equals 1 we know, period 1, we know whether we have ended up in the high scenario where P will be equal to PH, to the high price, forever. And if we have waited, then of course we will invest at that moment whenever PH over R is bigger than I. So if we do not invest today but invest tomorrow, we will invest, or next year we will invest whenever at that point in time present value is bigger than investment cost. And if on the other hand, of course, that we end up in the low scenario, we will invest next year as long as PL divided by R is bigger than I. That will be the rule next year if we forego investment now. So is there some value in this? So in the previous example, when all prices were constant, there was actually no value to waiting, but let's look at what's happening here. So if we do not invest today, not invest t equals 0, but if we do postpone until t equals 1, year 1, this investment decision, then what do we get? Well, with probability Q we will end up in the high scenario, and then we will get, well, the maximum of pH over R minus I, so the net present value, or 0 if that's negative. So we'll get that with probability Q if we end up in the high scenario. With probability 1 minus Q will end up in the low scenario, and then again we get the maximum of the NPV, PL over R minus I, and 0 if that turns out to be negative. In this probability 1 minus Q low scenario case. So what do we get in expectation then at period 1? Well, the average of this, right? The weighted average weighted with these probabilities Q and 1 minus Q. So today's view of next year's NPV will be the average of this first maximum and the second, the high scenario maximum, and this low scenario maximum, weighted with these probabilities Q for the high scenario and 1 minus Q with this low scenario. So what does it mean for today? Well, the present value of that today, period 0, is going to be a bit lower because again, of course, we have to do this discounting. So the present value, if we wait, is getting NPV1 but discounted by 1 year. So divided by 1 plus R to the power 1. Okay. So how much is that? So this NPV rule, what does that boil down to? So you have to compare these two, right? You have to compare, do we want to invest today, so get the expected NPV today, or do we want to postpone investment and get the discounted value of the expected NPV tomorrow? So it's going to depend on, whether when tomorrow arrives, we are going to make these investments. So let's assume that in all cases, the high scenario is, of course, going to be very large. So we'll make the investment certainly, but now we have to look at what happens in the low scenario. So suppose that even this low price, PL, is high enough to cause a positive NPV in period 1. So that PL over R minus I is indeed a number bigger than 0. Then we know what this expected NPV in period 1 is. That's again the weighted average of the high NPV, pH over R minus I, and the low NPV, PL over R minus I. Both of these are positive. So we'll certainly make this investment next year if we haven't made it already today. And the NPV that we get next year is the average of these two. So this average of these two is, of course, again the same as P bar over R minus I. So next year, basically, the NPV will be the same. The average NPV next year will be the same as today's expected NPV, P bar over R minus I. So if we have to make this decision, do we want to get NPV 0 now, invest now, or do we want to wait and get that same amount, but only 1 period later? So I'm sure you agree with me that waiting makes no sense, because if we wait, we get the same amount, but just 1 year later. So we miss out on discounting, basically by 1 on interest for 1 year. So if we wait, we get 1 divided by 1 plus R, so the discounted value of this thing. Whereas if we invest today, we get this NPV right away, and we prefer to get it right away. So if in either case, PH or PL scenario, we are going to make the investment anyway, well then there is of course no point in waiting. So the more interesting situation, of course, is when the low scenario is too low to make us want to invest. So suppose that indeed this PL, this low price, is so low that actually PL over R, the value of the cash flows in the low scenario, minus I is actually negative. So what does that mean? If we when we end up in period 1 and we see that we end up in the low scenario, we're just going to do nothing. We say, oh, prices are too low, that's unfortunate, but let's just not make the investment and get 0, right? So from the point of view of today, so what do we get? Well, there's still probably today there's still this probability that we might end up in the high scenario, this probability Q, and in that case we will make the investment, so then we get the high NPV, PH over R minus I. With probability 1 minus Q, we end up in the low scenario, but then we will not make the investment, so we get 0 here. So there's a 1 minus Q times 0 actually, which is, I didn't write here, of course. So that's now the NPV in that period 1. So should we wait or should we invest right away? So we have to compare again, right? So I have to compare the NPV of investing today or do we want to wait and get the expected NPV but in next period? So let's have a look at that. So it depends, of course, which one is bigger. In other words, is this difference between these two, the discounted expected NPV minus the NPV of investing today, is that going to be positive or negative? Now let's have a look at that difference. So which one is bigger, essentially? We can actually rewrite this, and so let me rewrite this for you a little bit on paper, and I will get back to the slide to see why this particular expression holds. So if you want to do this yourself, I encourage you to do so. So just pause the video and see if you can indeed figure out that the expression we have over here can indeed be rewritten as the expression that you see here. And I'll do that on paper now, so just stop the video if you want to do that yourself. So here we go to paper. So we are interested in 1 divided by 1 plus r times this NPV, expected NPV in period 1, and the difference with the NPV of investing today. And of course this NPV of expected NPV of period 1 of investing only, of waiting and investing period 1 is, you can write it as seen that is Q times PH over R, that's present value minus the investment cost multiplied by the probability that you end up in the high scenario. And let's rewrite this a little bit as the average value which is this thing plus 1 minus Q times this PL over R minus I, right? That was what this average value was. Minus, of course, I'm overcounting this negative scenario, so I should subtract that. Minus 1 minus Q PL over R minus I. So the positive branch, if you wish, is the average branch minus the negative branch of this probability process. So let's use that in computing this difference here of these two NPVs. So this 1 divided by 1 plus R times NPV1 minus NPV of 0 is, let's write this. Let me first take the second term over here. So I'm multiplying that by 1 divided by 1 plus R. So it gives me the minus 1 minus Q divided by 1 plus R PL over R minus I. So that's this term over here times the 1 over 1 plus R. So it gives me this first part. Then we have plus 1 over 1 plus R times P bar over R minus I, but minus the NPV itself, which is 1 times P bar over R minus I, right? So this thing here is actually NPV 0, it's this average NPV. So it's, we can write it, we can grab those terms together and write it as this discounted part, 1 over 1 plus R times NPV1 times this expression, minus 1 times the NPV of 0, which is, again, this P bar over R minus I. So the NPV 0 is, of course, P bar over R minus I, right? So I've taken together these two terms. Okay, so let's rewrite that a bit. So this first part is already what we need. Let me copy that. Now what's 1 divided by 1 plus R minus 1? Well, we have to do a subtraction of fractions. I'm sure you can do that. So and then that of course gives give me a minus. Write that immediately here. Gives me minus R divided by 1 plus R, because here we have 1 plus R divided by 1 plus R, so I get 1 minus 1 plus R, which gives me minus R divided by 1 plus R times P bar of R minus I, and now finally let me multiply the R over here into these brackets, equals minus 1 minus Q over 1 plus R, PL over R, just copying this, minus 1 divided by 1 plus R times P bar minus R I, right? So I just multiply this R in here. Okay, so and this was actually what I wrote on the slide. So let me now get back to this slide. So here you see that same expression again. So of course it's the same as, so I might get it write it in a different way, but there's a reason, of course, for doing this, and the reason is that this gives us some intuition. So that's, you know, general rule. If you do math, you do the math not to get an answer, you will do the math to get a formula which gives you intuition. That's why you do math, right? It's not for getting a result, it's for getting intuition. That's why we do economics and not just computation here, right? Okay, so what are these two parts? Well, this one should be sort of obvious. This is the loss of, so P bar minus RI is the 1 period income, right? So the average 1 period income is, you get the average price. The average 1 period cost was the capital cost, R times I, and you get so these are the benefits of investing today, and you're missing out on these benefits for the first period. So by waiting, you will get those benefits only 1 period later, so you miss out of the first period's benefits. So the first period, so discounted by 1 plus R, so this is the present value of the first period benefits that you are throwing out of the window if you wait. So that's why there's a minus here as well. So this other part here, you know, what's that? So I wrote here the gains from avoiding the bad scenario. So of course, bad scenario, this is what the NPV of investing in the bad scenario, right? When does that happen? Well, with probability 1 minus Q. And I will only get this divided by 1 plus R. But of course, we have to remember that we are assuming here that we are not going to invest in the bad scenario if you can help it. So PL over R minus I, in the case that we are considering, was a negative number. So you see the minus over here times a negative number. So this is a positive number. So the good thing about waiting is that we are avoiding getting this negative NPV from the bad scenario. So the value of avoiding that bad scenario depends on how likely this bad scenario is, 1 minus Q. And we have to discount this once because we're going to get this one period later. So this is all in all, this whole thing here is a positive term. That's a benefit of waiting, and this is the cost of waiting. So when do we want to wait? Well, as long as these benefits, these gains from avoiding to get into the bad scenario with your project and getting losses all over the place, when those outweigh basically the disadvantage of postponing, you know, that we haven't seen all the time before, the disadvantage of postponing your whole project, and you know, the average positive cash flows for 1 period. So if this avoided loss, this first part, is sufficiently big, then the benefit of waiting is going to be positive. So the optimal decision here should be, let's wait until we see whether we're in the high or the low scenario, and only then let's make this investment. So what is the result here? So as long as indeed this value of waiting, so this difference between investing later and versus investing now, is bigger than 0, then it makes sense. Even if NPV 0 is already positive, it makes sense to postpone these investments 1 period more, because then we can learn from the future, from what's going to happen, and this learning basically has value. So where does this value come from? It originates from the opportunity or the ability that we can, after waiting for 1 year, we have an ability to tailor our decision making, this future decision on what we see in terms of prices, these future prices. So once we do have made the investment, so if you make investment today, this thing is irreversible. So we are locked in basically, you know, for good or for bad. And if this bad is sufficiently bad, and then that lock-in might be sort of undesirable. So if you invest now, another way of saying this is if you invest now, it means you are throwing away this learning value, so this ability to tailor our future decision or future prices. We're throwing away that value, and that value is actually kind of option value. So in that sense, postponing, or the ability to postpone the investment, opportunity to postpone investment, is actually an option. It's not a financial option, it's a real option. It's an option on a real asset. So it's like a financial option, like a call option, in the sense that we can either choose to exercise this option now and get say the stock at the strike price today, or we might actually wait a bit and exercise this call option just a bit later if it has not yet reached its end date, its maturity date. And what do we do? Well, if we exercise today, we are throwing away the intrinsic value of this, the time value essentially of this call option, and that has value too. So we have to take into account the time value, if you wish, of this option. And option value, this time value, basically arises because we can in future base our future decisions on the future price movements that we can then observe. So a real option is just like such an option, but it's an option on a real asset. It's an investment project, it's this power plant, if you wish, rather than a financial asset like a stock or a bond. So this is one, the basic example basically of a real option. So there are more types of real options on irreversible decisions that you might imagine. So one might be, and I actually mentioned this earlier, the option to expand the firm. So sometimes you have the ability to wait a bit to see where prices go, and only then decide, do I want to expand the capacity of my plant? Do I want to upgrade basically the capacity of my plant at a later date because the market turns out to be so good for us? If the market, on the other hand, market prices go down, then you might have the ability to discontinue your operations rather than keep on operating at a loss. You have the option to abandon operations if price goes down. And again, you will wait for this, and this option has a value. Sometimes you might not have to completely abandon, but you can just actually shut down your plant for a little while until price recovers again and gets above zero again. So it might be the option to suspend your operations. Sometimes you have the option to choose the mode of your operation. So if your plant can operate into different, using different technologies, and in one type of circumstances you might be able to use one circumstance, and you might be able to switch, have the option to switch essentially at some future point if some competing technology becomes more profitable at that point in time. So all these choices that you can make, and that you can make depending on movements of, say, prices or of costs over time, that you will learn over time, all those will be real options that have values. So real options have values. Well, if they have values, they will also affect investment decisions because those will reflect those values. So it makes sense to ask questions, so what is this value? Because that's going to impact on my decision. But on the other hand, the decision itself, or in particular the future decisions that I will be making, they will impact on the value. So we have to think about what will in the future be the optimal decisions that we will take depending on what the future brings. So the option value derives from those actions that you will make in the future, and these actions will depend or are contingent on movements of prices or costs, or perhaps some other parameters like subsidies, for instance. And they will depend on those and contingent on those, and we will take into account that we are going to make the optimal decision given the information that we have at that point in time. So if we wait until the future, at the future point we will have learned a bit, and we're going to assume in computing today's value of that future decisions that tomorrow we are going to make the decision that at that point is going to be optimal. So we have to figure out what are the optimal decisions. So in the simple example that we just looked at, there was just one decision. There was only just one movement basically in prices in period 1, and we just had to compare do we want to make the investment today, or do we want to make this investment tomorrow? Now, this is of course not as far cry essentially from reality, because usually these prices will keep on moving also in the further future. So we have to find the optimal decision now when price keeps on moving. So that will turn out to be a slightly bit more complicated. So here's actually a figure which describes the price movement. So today we might sit at this point where we can observe the price. We know that tomorrow or next year prices might go up, increasing by some amount delta, or they might go down, decreasing by some amount of delta. But then again, year afterwards, again price might go up to P plus 2 delta, or perhaps in the year afterwards actually price might go down, and similarly here. If we end up to next year at P minus delta, price might recover and go back to P, or they might decline further to P minus 2 delta, etc., etc. So this whole tree, as it's called, and it extends all the way until infinity, and prices might go all over the place essentially. And then again, the question is, when should we invest? Should we invest now, or should we wait 1 year until here or here? After 1 year, we know the first step essentially. And again, after 1 year, we have to think: do we want to make the investment, or do we want to wait 1 more year until we are in year 2, which would happen here? Well, we might have gone up once again, or we might have gone back to this original price P. What should we do? So when should we invest? To answer that question, actually, we'll have to look at how can we actually figure out how can we compute optimal decisions, and to do that, we'll introduce the Bellman equation in the next video.